I have created 2 videos for FreeCAD 1.0 assembly to go through all the functions and make few examples specially for gear joint. To watch the previous 2 videos, please follow the link in the description below. With these examples, I found some more functions or different ways for creating joints. At the very beginning, I thought the screw joint was limited to move the nut to rotate the screw. But actually, I can move and rotate the screw at the same time. Then this can be used in many animations or for testing the design. Besides, usually the rack is fixed in the rack and pinion joint. Moving the gear over the rack is also possible by this default assembly. Ball joint is not just a ball joint. It can be used as point-to-point constraint or for wobbling a disc. Let me start to see how these joints work. To create a screw joint between a nut and a screw in the first part of the video, create a new file. In the Assembly Workbench, create Assembly File. Insert Component, Open File. From the directory where I store the part files, open the file line. Select the body line, click Yes to ground the item, as at least one component must be fixed to start the assembly. Click OK. Insert Component again, insert the file's nut and screw. Rotate and move the screw. Double-click the nut to get Transform tool, rotate the nut. Now I will create a slider joint between the nut and the line. Because I need to slide the axis of the nut along the line, I select the circular edge of the nut instead of a straight edge of the nut. Select the line. Create slider joint. Then select the circular edge of the screw and the line, create revolute joint. Go to the nut. View, change transparency to 80. Return to the assembly. Move the nut to mesh with the screw. Select the slider joint and the revolute joint to create a screw joint. Select the circular edge of the nut to get the axis for sliding, and the circular edge of the screw for the revolute joint. Create screw joint. Pitch radius is in fact the pitch of the screw. 1.5 mm for M10 screw. The joint is created. Move the nut will rotate the screw. The rotation direction is correct. The screw joint is completed. It is similar in the example linear actuator I created before. Instead of moving the nut to rotate the screw, I will try to move and rotate the screw at the same time and keep the nut fixed. Let's move to the next example. Create a new file. In the Assembly Workbench, create Assembly File. Insert Component. Insert the line and click Yes to fix it. Insert the nut, rotate and move it. Insert the screw, rotate and move it. Open file line A, which is a shorter line. Insert component, insert line A, move it out from the long line. Select the short line and the long line to create a slider joint. Select line A and move it away from the long line. Select the circular edge of the screw and the short line. Create revolute joint. I can drag the line from the top of the screw to move the screw. The screw rotates about the line. To fix the nut to the line, select the circular edge of the nut and the line, apply fixed joint. Move the screw to mesh with the nut, but the short line overlaps with long line. So, select line A and move it out first. Resolve constraints. Move the nut to the end of the long line. Next time, I should make this line shorter too. Open the fixed joint, adjust offset. Now move the screw to mesh with the nut. In order to create a screw joint, I need a slider joint and a revolute joint. However, I cannot create these two joints on one component because once a revolute joint is created, the component cannot slide. So the revolute joint is now created between the screw and the line, and the slider joint is set up between two lines, and I can use these joints to create the screw joint. When select the line from the slider joint, I cannot select the short line. It is because the revolute joint is set up between the screw and the short line. Creating a screw joint between these two items again would not work. Beside these two items, only the long line is available and it is part of the slider joint. Use the long line and the circular edge of the screw may be able to create a screw joint. So select the long line and the circular edge of the screw. Create screw joint. The pitch radius is in fact the pitch of the screw. With M10 screw, the pitch is 1.5 mm. Hide the long line. Drag the short line to move the screw. When the screw moves forward, it rotates clockwise. The rotation direction is correct. With same approach, I will create a vise assembly and use screw joint to move the jaw but without using a supporting line. This section is to create a simple vise assembly. Create a new file. Create new assembly file in the Assembly Workbench. Insert component, open file. Open the file vise base, insert the item and click Yes to ground the component. Insert part moving jaw. Select the edge of the moving jaw and the edge of the base, create slider joint. Open the slider joint, move the item to the left and click min length. Then move the jaw to the desired position and click max length. Move the jaw and it can slide only within these limits. Insert component, open file. Insert the handle. Rotate it by roughly 180 degrees. Select the circular edge at the threaded pipe and the circular edge at the moving jaw. Create revolute joint. Go to the item vice base, select Cut, and change the transparency to 80. Go back to the assembly. Move the jaw so the thread of the pipe mesh with the threaded hole at the base. Select the circular edge of the handle and the edge of the base, not the edge from the jaw. Create screw joint. Pitch is 1.5 mm for M10 thread. Move the jaw and the threaded pipe move and rotate. The approach is same as for moving the screw in the previous section. This section is to create a rack and pinion joint, but the rack is fixed and the gear is rotating and moving. Create a new file. Create new assembly file in the Assembly Workbench. Insert component, open file. Open the rack, insert the item and click Yes to ground the component. Usually the rack is moving, but in the example, the rack is fixed. Insert component, open file. Open the file slider block, insert the block. Rotate it and move it. Select the edge of the rack and the edge of the block. Create slider joint. The block slides along the rack. Attach the gear to the block so it slides over the rack. Insert component, open file. Open the file gear. Insert and move the gear. Select the circular edge of the gear and the circular edge of the block. Create revolute joint. Rotate the gear to mesh with the rack. Now I can create the rack and pinion joint. Select the circular edge at the gear, then select the edge of the rack, not the edge of the block, although it is the moving part of the slider joint. Create rack and pinion joint. The pitch radius is 10 because the gear has 20 teeth. Use half of the number. The actual radius in mm is not needed. Click OK. Save the file before test the direction. Move the block to rotate the gear. The rotation direction is wrong. Close the file and discard any changes. Reopen the file. Open the rack and pinion joint. Change distance to -10. Need to activate the assembly first. Test it again. The direction is correct now. In A2+ Workbench, there is a point-to-point constraint, but apparently, it is not in the new Assembly Workbench. Sometime, I do need this when other constraint is not applicable or not convenient to use. Let me do a point-to-point constraint by this example, flexible coupling. Create a new file. Switch to Assembly Workbench. Create assembly file. Insert component. Open files flange A, flange B and the spider. Insert flange A. I don't want to ground this item. So, I click No. Insert flange B and the spider. Select flange B and click the red lock to fix this component. Select the circular edge of the spider and the circular edge of the flange, create revolute joint. Select straight edge of the flange and the straight edge of the spider, create slider joint. The spider is fixed to the flange. Let me try another approach. Delete the joints. Select the point at the spider and the point at the flange. Create ball joint. Do it again for the other side. Select the point at the spider and the point at the flange. Create ball joint. Need one more constraint to fix its position. Select the surface of the spider and the face of the flange. Create parallel joint. The spider is fixed at the flange. Select the surface of both flanges. Create fixed joint. The assembly is smart enough to put them together and match two rectangles. Rotate it 180 degrees. I can bring the screws into the assembly but cannot insert it into the hole with the assembly. I have to insert the screw directly from the fastener workbench. So, switch to Fastener Workbench. Select the hole and choose the screw. It will be inserted. The position is not correct, we'll deal with it later. Repeat for the other hole. Select both screws by holding the Shift key. At the parameter field, invert, change it to true. The screw position is correct now. Select both screws and change them to M6 and 35 mm long. Besides, the ball joint can be created between a plane and a line, a plane and a plane, or with round surface. The joint is created between the center of these bodies. Let me do a quick demonstration about this. Create a new file and insert files line and round plate. Select the circular edge of the plate and the line, create ball joint. The plate can wobble about the line. Finally, I have some notes for the advanced offset. For this simple example, I just open the file I created. There is an inner ring and two balls. Select the ball and the circular edge of the ring, create revolute joint. Offset -7 mm and the ball will be at the center of the ring. Show advanced offset, open offset window 1. Change X to 20 mm and the ball will seat on the inner ring. Rotate the ball and you can see the axis of rotation of the ball is still at the center. It won't be affected by changing the position of the ball. Try another ball. I didn't hold the control key when selecting these items, so the window is empty. Anyway, I can select the item one by one while the window is open. Select 2 balls and create a distance joint. Two balls rotate around the ring with fixed distance. With the previous videos I created, I think it is a good start for covering the basic functions of the Assembly Workbench. If you find this video interesting and informative, please subscribe and give it a like. Thank you for watching.